So we launched this effort a few years ago to really ask and answer the question, what will networks be like in the future? That led us to a project that we call CROSSMobile, where we run an open software-defined LTE network on campus. We wanted to measure our signal strength. So that led us to the project of building some instrumentation so that we could walk around. Well, we didn't like to walk around too much, and we decided it would be interesting to strap those sensors on drones. And that opened up a whole range of research questions in the relationship between drones as things that would measure a network's performance, to drones being elements of the network, to drones being used in swarms to track targets, to participate in humanitarian assistance and disaster relief, pipeline inspection, and that led us to using neural networks on drones. One of the projects that we're working on right now is aerial reinforcement learning. So we built technology that lets the drone essentially take off with the expertise of a 4-year-old in recognizing physical objects in the world, but the 4-year-old doesn't know exactly what you're looking for. What we then created was the ability to kind of provide flashcards to the 4-year-old. So as the drone is flying, it's sending back still images of what it sees. And an operator on the ground could say, yes, the object of interest is in the image, or no, it's not. And within about a minute or two, the drone very quickly gets it about what the object is that we're looking for. We recently did an experiment where we sent some drones up, one first, to recognize light poles, sort of to simulate a city infrastructure inspection kind of thing. So the drone went up, it knew nothing about light poles. So the drone is scanning around. The operator on the ground sees the images. There's a light pole in the picture, pushes a button that says, yes, this is an interesting image. And then when the camera pans to some other areas where there isn't a light pole, we'll say, no light pole there. And pretty quickly it recognizes light poles. Well, that's great, except for the fact that the drone's battery only lasts for about 15 minutes. So as the drone is landing, we've now developed a capability of taking a second drone off the ground and transferring that knowledge that the first one gained about how to recognize light poles into the second one. So the first one can land, and then the second one now is beyond the 4-year-old's knowledge. It has 4-year-old's knowledge plus light poles. So the ultimate impact of this research comes when we realize that what we're creating is a new kind of computing platform. Doing this work on drones today, where we're pushing very hard to put all the computation on the drones, and drones, by the way, have big batteries, so we don't have to worry about power, helps teach us how to distribute computing in a way that can be energy efficient in the future, and eventually will make its way into all of the little tiny sensors that are scattered throughout the environment. And above all of it is some way of programming these intelligent sensing devices, whether they're camera sensors on drones or sensors in the pavement. We'd like to be able to program that in the same way.